where we're going to completely demystify something we've all seen out on the road: a diesel truck leaving a massive, dark cloud in its wake. Now, we aren't just going to run through some basic run-of-the-mill mechanics checklist today. Oh no, we're going straight into the fundamental physics and thermodynamics of your engine to figure out exactly why diesel engines produce black smoke, what it actually is, and how you can master the science of making it stop. To kick things off, let's look at this core question. Why is it that a diesel engine can literally black out the sun with this thick cloud of soot, while a poorly running gas engine just kind of sputters and stalls out? It's a really fascinating scientific journey, and the answer completely lies in the different ways these two engines breathe, mix their fuel, and ignite it. Section 1. The charcoal engine, defining the black smoke mystery. First things first, we've got to shatter the illusion that black exhaust smoke is some kind of complicated, unsolvable mystery. It really all comes down to a super simple foundational equation: intense heat plus limited oxygen equals carbon soot. You see, when fuel is exposed to extreme heat but just doesn't have the oxygen it needs to actually burn completely, the chemical bonds break down, those carbon molecules clump together, and they exit your tailpipe as black soot. Think about making charcoal out of wood. You don't actually set it on fire, right? You bake it in an oven with very little air. That intense heat breaks down the wood, vaporizing the water and gases, and leaving behind just pure carbon. Well, the exact same thing is happening inside a diesel cylinder when there's a lack of oxygen. You aren't burning the fuel, you are literally baking it into liquid charcoal. Moving right along to Section 2. The science of diesel combustion, working principles. Okay, so why does this whole charcoal baking process happen almost exclusively in diesels? Well, it really comes down to how they ignite. Gas engines use spark plugs to ignite a perfectly mixed, completely homogeneous mixture. If it gets too rich, the spark plug just drowns, so no fire, no smoke. But diesels? They rely on extreme compression. They heat the air to over 1,200 degrees, spraying the fuel in at the very last microsecond, so it auto-ignites right on contact. Because that fuel gets injected at the literal last possible millisecond, a diesel operates using what engineers call heterogeneous combustion. It's highly stratified. This means that inside a single cylinder, in just a fraction of a millisecond, you have distinct areas that are perfectly mixed, areas that are way too lean, and areas that are flooded and way too rich. So even if a diesel is running lean overall with plenty of air, there are these localized, rich pockets of liquid fuel desperately fighting for limited oxygen. I love this analogy. Imagine those vaporized fuel molecules as little Pac-Men navigating a maze. They are basically relying on the physical swirling and tumbling of the air inside the cylinder to frantically hunt down oxygen dots. And they only have a fraction of a second to eat an oxygen dot before that exhaust valve pops open. If they can't find one in time, game over. They bond with each other, form a carbon gang, and boom, they turn into black smoke. All right, let's get into Section 3, disrupted combustion, the 5 root causes. So what actually throws off this delicate game of molecular Pac-Man? Well, there are 5 primary mechanical culprits that are going to cause your diesel to smoke. Number 1, a dirty air filter. 2, faulty fuel injectors. 3, a worn or damaged turbocharger. 4, carbon buildup right in the combustion chamber. And 5, a clogged EGR, or exhaust gas recirculation valve. Every single one of these issues does one of 2 things. It either completely starves the engine of the oxygen it desperately needs, or it floods it with poorly mixed fuel. Let's break down exactly how these failures mess with the combustion chamber. Take a clogged air filter, for example. It's like trying to run a marathon while breathing through a straw. It causes immediate air starvation. Or a stuck or worn fuel injector. It loses that precise misting ability. So instead of a fine spray, it creates these fuel puddles that just can't possibly find enough oxygen to burn. A worn turbo fails to force that dense air into the engine, and a clogged EGR valve practically chokes the engine on its own recycled, dirty exhaust. And the result for all of them? You guessed it, unburned carbon molecules. Which brings us to Section 4, diagnosis and correct solutions, finding the real fault. Knowing the parts is one thing, but how do we actually fix them? Here is the absolute golden rule. Do not just start throwing expensive parts at your engine. You have to follow a strict diagnostic logic. Step 1 is always basic visual checks. Seriously, inspect that $20 air filter before you even think about replacing a $2,000 turbo. Look for cracked hoses that might be causing boost leaks. Then, Step 2 is testing your boost and airflow. Step 3 moves into specialized fuel system testing, like checking common rail pressures. And finally, Step 4 utilizes scan tool diagnostics to check sensor data and fuel trims. Always start cheap and logical, then move on to the complex stuff.
This diagnostic logic completely separates a frustrated owner from a smart one. A huge mistake is just ignoring light black smoke during acceleration, thinking it's just a diesel thing. Or maybe wildly guessing and blindly replacing injectors, hoping that'll cure it. The proper fix relies on timely maintenance and professional step-by-step diagnosis. Think about it. Fixing a boost leak in a rubber hose takes minutes. Replacing an entire engine because you ignored it? That takes weeks. Now, we really need to talk about why this matters. Because the long-term technical impact of ignoring black smoke, it is absolutely brutal. Let's be clear, this isn't just about failing an emissions test. Unburnt fuel can literally wash the vital lubricating oil right off your cylinder walls. It dilutes your engine oil, completely destroying its protective properties. It will rapidly clog your diesel particulate filter, or DPF, which leads to thousands in repairs, and it drastically accelerates your turbo and engine wear. Smoke is a symptom, sure, but it is a symptom that creates deadly secondary diseases for your engine.
And finally, Section 5, the ultimate trade-off, power versus efficiency. Okay, let's explore a really fascinating expert-level paradox that might completely flip how you look at black smoke. Up until now, we've established that smoke means inefficiency and broken parts, right? If you want maximum efficiency, saving fuel and protecting the environment, you run the engine lean with tons of excess air and zero smoke. But if your goal is absolute maximum horsepower on a racetrack, the rules completely change. To get max power, tuners will cram as much fuel as physically possible into the cylinder, aiming for a super rich 14.5-to-1 ratio. The engine can't possibly burn it all cleanly in the allotted time, so it produces heavy black smoke. But actually burning most of a massive amount of fuel still yields way more raw power than burning a small amount perfectly cleanly. Mind-blowing, right?
So this brings us to our final thought. The very next time you see a diesel puffing out a massive black cloud, ask yourself, is that truck purpose-built for the drag strip, intentionally sacrificing efficiency to push the absolute physical limits of horsepower? Or is it just a daily driver with a clogged air filter and leaking injectors, practically crying out for some basic maintenance? Well, understanding the science means you now know the difference. Thanks for joining me for this explainer, and I really hope this helps you master the mystery of diesel black smoke. Catch you next time.